It weighs 1,150 kilograms. That is the number stamped in the factory records, the number the designers calculated on their drafting tables in Gorky in the autumn of 1941. And it is the number that determined everything that followed. Because 1,150 kilograms is light enough for 4 men to lift it over a ditch, light enough to drag by hand across snow when the horses are dead, light enough to manhandle up a staircase and fire from a second-floor window of a burning building. The barrel is 3.5 meters long and 76 millimeters in diameter at the bore. The breech mechanism is semi-automatic, meaning the spent case ejects automatically on recoil, and the breech reopens ready for the next round. And a trained crew operating under ideal conditions can put 15 aimed rounds through that barrel every 60 seconds. The split trail carriage folds to a narrow track width that allows the gun to be towed at highway speeds. The shield is 4 millimeters of hardened steel, which stops rifle fire and shell splinters and is entirely useless against an anti-tank round, but is not there to stop an anti-tank round. It is there to stop the things that actually kill gun crews in combat, the 1,000 small projectiles that fill the air around an artillery position under fire. The whole assembly sits low enough to the ground that a crew can push it behind a wall, behind a ruined building, behind a shallow fold in the earth, and in the right hands, in the right terrain, with the right ammunition loaded, it becomes something the German tankers who first encountered it in the winter of 1941 struggled to describe accurately in their after-action reports. They called it fast, they called it everywhere, they called it impossible to find until it had already fired. They said it killed tanks that were not supposed to be killable. The gun is the ZIS-3, the 76mm divisional field gun model 1942, and by the time the war ends, it will be the most produced artillery piece in the history of the Soviet Union. Over 103,000 examples manufactured in 4 years. It will serve on every front the Red Army fights on, in every climate from the Arctic approaches of Murmansk to the subtropical marshes of the Kuban. It will kill more German armored vehicles than any other Soviet weapon system in the first 2 years after Stalingrad. Its crews will give it no glamorous nickname. They will call it the Sorokopiatka's bigger brother, or simply the 76, or sometimes in the cold shorthand of men who live with a piece of equipment long enough to understand it completely. Just Ona, she. The Germans, by contrast, will develop several names for it, most of them unprintable, and the one that survives in the historical record is the one the tank crews of the Wehrmacht coined after the encounters in which the gun demonstrated, beyond any reasonable argument, what it could do to the armor they had been told was invulnerable. Beast Killer. The story of how a gun earns a name like that is not simply a story about metallurgy and ballistics, though it is also those things. It is a story about a country that is losing a war so catastrophically in the summer and autumn of 1941 that the men tasked with designing its weapons have no time for committees, no time for trials, no time for the institutional processes that turn a concept into a production order in a country that is not being destroyed. It is the story of a single engineer who makes a decision that contradicts his superiors, who builds the gun anyway, who is nearly arrested for doing so, and whose gun then saves an army. It is the story of the men who operate it, the anonymous gunners and loaders and layers who are gone from the historical record almost entirely, who fought in conditions so extreme that the guns froze and the crews burned their coats to keep the ammunition warm enough to fire. And it is the story of what happens when a weapon of exceptional quality reaches the hands of soldiers who have learned, through catastrophic suffering, exactly how to use it. To understand why the ZIS-3 matters, it is necessary to understand what the Soviet artillery situation looks like in the summer of 1941, which is to say, it is necessary to understand a disaster. Operation Barbarossa begins on June 22, 1941, along a front stretching from the Baltic Sea to the Black Sea, approximately 3,000 kilometers. The Wehrmacht and its allies commit over 3 million men, 3,000 tanks and 7,000 artillery pieces. What they find is a Red Army that outnumbers them in almost every category of equipment: more tanks, more aircraft, more artillery, and is paralyzed anyway for reasons that have nothing to do with hardware. The officer corps has been decimated by Stalin's purges of 1937 and 1938. Communication networks collapse in the first hours of the assault, when German aircraft destroyed telephone exchanges and headquarters buildings. Entire armies are encircled and destroyed before they can organize a coherent response. The Soviet tank force, which is the largest in the world on paper, loses 2,000 vehicles in the first week, not primarily to German anti-tank fire, but to mechanical breakdown, to fuel shortages, to crews who have received 30 hours of training on machines that require 300, to the simple fact that a force that enormous cannot be led coherently when its leadership structure has been systematically murdered. The artillery survives better than the tanks, initially because artillery does not move as quickly, and the encirclement battles that destroy Soviet mechanized formations sometimes allow artillery units to escape on foot. But what escapes is in most cases the guns themselves, not the equipment needed to make them function. The trucks, the horses, the ammunition stockpiles, the communications equipment, the fire control instruments. By the autumn of 1941, the Red Army is rebuilding from a position that is not merely weakened but structurally broken, and the artillery it has available is a bewildering mixture of calibers, some dating to the First World War, with incompatible ammunition, incompatible parts, incompatible doctrine, and a manufacturing base that is simultaneously trying to move itself across the Ural Mountains to escape the German advance. It is in this context that Vasily Grabin makes his decision. Vasily Gavrilovich Grabin is 41 years old in 1941. He was born in 1900 in the Kuban, the agricultural heartland of southern Russia, to a family of modest means, and he has spent his entire adult life in the Soviet defense industry, rising through a system that rewards political reliability and production numbers in roughly equal measure. By 1934, he is the chief designer at Factory No. 92 in Gorky, the industrial city on the Volga that will become one of the most important weapons manufacturing centers of the entire war. Grabin is not a theoretician. He is an engineer in the most practical sense of the word, a man who understands what happens to a gun design when it meets the realities of mass production, of unskilled labor, of raw materials that arrive in wrong grades and wrong quantities, of assembly conditions that bear no resemblance to the controlled environment of a design bureau. He has already designed the F-22, a 76mm divisional gun introduced in 1936, and the F-22 USV, an improved version introduced in 1939. Both are capable weapons by the standards of their time. Both are also more complex than they need to be, more expensive than they need to be, and more difficult to manufacture in the quantities that a war of this scale will demand. The F-22 USV requires approximately 1,000 machine hours to produce in a fully equipped facility. Grabin understands with a clarity that the official production committees do not yet share, that this number is going to be catastrophic when the factories begin to lose their skilled workers to the draft and their machine tools to the chaos of relocation. He begins the design of a new gun in early 1941, before the German invasion. The concept is straightforward enough to state and extraordinarily difficult to execute. Take the ballistics of the existing F-22 USV, the 76mm bore, the same ammunition, the same velocity, the same penetration, and package them into a carriage that can be manufactured in half the time, by workers with half the training, in facilities with half the equipment. Strip out every component that exists for elegance rather than function. Eliminate every machining operation that serves precision without serving performance. Designed for the production line that will actually exist in 1942, not the production line that exists on paper. The carriage he settles on is derived from the ZIS-2, a 57mm anti-tank gun, that factory number 92 is already producing in small numbers. The ZIS-2's carriage is light, robust, and already in production, which means the tooling exists and the workers know it. By mating the F-22 USV barrel and breech group to a modified ZIS-2 carriage, Grabin achieves something that the design committees of the main artillery directorate have not managed. A weapon that performs to the existing tactical specification but can be manufactured in approximately 500 machine hours, roughly half the time of the weapon it will replace. He calls it the ZIS-3 for Zavod imeni Stalina, factory named for Stalin, number 3. What happens next is the part of the story that the official Soviet histories will handle delicately for decades. Grabin does not submit the design through normal channels. He does not wait for approval from the main artillery directorate. He does not convene a committee or request a trial schedule. Instead, in the autumn of 1941, with German forces approaching Moscow and the entire Soviet state in a condition that can only be described as controlled disintegration, he simply begins manufacturing the gun. He diverts materials, he assigns workers, he builds the prototype, he builds several prototypes, and then, in a step that under different circumstances would have ended his career and possibly his life, he presents the artillery directorate and, ultimately, Stalin himself with a fait accompli. Not a proposal for a weapon, but a weapon fully functional, ready for trials, already proven in the factory yard. The trials take place in the winter of 1941 into 1942. By some accounts, Grabin personally attends every day of the test program, standing at the firing position in temperatures that sink below -20 degrees Celsius, watching the gun perform against targets at ranges from 200 to 1500 meters. The ZIS-3 passes every test. It passes the cold weather test because Grabin has designed the recoil mechanism to function at temperatures the existing guns cannot tolerate. It passes the mobility test because at 1,150 kilograms it is light enough to be manhandled by its crew without mechanical assistance. It passes the accuracy test because the ballistics are unchanged from the F-22 USV, and the carriage's stability at the firing point is superior. And it passes, most critically, the penetration test against the armor of German Panzer III and Panzer IV tanks, which are at this point the backbone of the Wehrmacht's armored force, and which the existing Soviet anti-tank weapons are already struggling to defeat reliably at combat ranges. Stalin approves the ZIS-3 for production in February 1942. The formal designation is the 76mm divisional gun M1942, production at Factory No. 3. 92 begins immediately, and the manufacturing numbers that follow are staggering by the standards of any industrial nation that is not the Soviet Union at war. In 1942, the factory produces approximately 10,000 guns. In 1943, it produces nearly 14,000. By the end of the war, total production exceeds 103,000 examples, a figure that represents not just manufacturing volume, but the triumph of Grabin's fundamental design insight that a weapon optimized for production is, in the conditions of a total industrial war, more valuable than a weapon optimized for performance, as long as it performs well enough. The gun reaches the front in the spring and early summer of 1942, and what happens there requires some understanding of what Soviet artillery doctrine has been attempting to become since the catastrophe of 1941. The Red Army's artillery philosophy before the war was sophisticated on paper and chaotic in practice. The theoretical framework, developed by Mikhail Tukhachevsky and his circle of military intellectuals before Stalin had most of them shot, called for the deep integration of artillery with armored and motorized forces, for centralized fire control at the operational level, for massive concentrations of tubes at decisive points. The practice in 1941 was the opposite of all of this. Artillery was scattered, decentralized, used in penny packets to support local infantry actions, led by officers who had been promoted to fill the gaps left by the purges and who in many cases lacked the experience to employ their guns at ranges beyond direct observation. What the ZIS-3 arrives to fight is a war that has already begun to impose a brutal pedagogy on the survivors. The officers who have lived through 1941 and the first half of 1942 are not the same officers who began those campaigns. They have learned, at a cost measured in hundreds of thousands of lives, what works and what does not work in the specific conditions of the Eastern Front. And what they have learned is that the gun, the field gun, the anti-tank gun, the gun in direct support of infantry, is the decisive weapon of this war, more than the tank, more than the aircraft, more certainly than the rifle. The ZIS-3's entry into service coincides with, and materially contributes to, a shift in Soviet tactical practice that the German after-action reports of 1942 and 1943 record with increasing alarm. Where Soviet anti-tank defenses in 1941 had been largely passive, guns dug into fixed positions, waiting for tanks to approach, the new doctrine that emerges around the ZIS-3 is fundamentally mobile. The gun's light weight and narrow trail width allow it to be repositioned quickly, even under fire. Crews learn to displace after every third or fourth shot, to set up alternate positions in advance, to use terrain in ways that the heavier German anti-tank guns cannot replicate. The split trail, which allows the gun to traverse a full 60 degrees to each side without moving the carriage, gives a crew that has prepared its position correctly an enormous engagement arc. A single gun, properly sighted, can cover an approach that a German armored commander might not recognize as a killing ground until the first round strikes his lead vehicle. The ammunition available to ZIS-3 crews is a further element in the weapon's effectiveness that deserves specific attention because it is not static. In 1942, the primary anti-tank round is the BR-350A, a capped armor-piercing projectile that at 500 meters, striking vertical plate, can penetrate 76 millimeters of hardened armor. This is adequate against the Panzer III and Panzer IV as they exist in 1941 and early 1942. The Panzer IV's turret front is 50 millimeters, its hull front 50 millimeters as well, and at the combat ranges the Eastern Front typically produces, a ZIS-3 can kill it reliably. Against the Tiger I, which begins appearing on the Eastern Front in the autumn of 1942, the situation is more complicated. The Tiger I's frontal armor is 100 millimeters of plate at essentially vertical angles. The designers have not yet learned to add slope, a decision they will regret. 100 millimeters is beyond what the standard BR-350A can penetrate at any reasonable combat range. The gun crews know this. The tank commanders know this. The tactical response on both sides is immediate and shapes the fighting of 1942 and into 1943 in ways that the armchair strategists have not accounted for. For Soviet ZIS-3 crews confronting a Tiger, the solution is a combination of patience, positioning, and flanking. The Tiger's side armor is 80 millimeters, its rear armor is 80 millimeters. A ZS-3 round at 300 meters, striking the side of a Tiger's hull, can defeat that armor. The tactical problem is getting a shot at the side or rear, which requires either setting up a position that the Tiger will drive past without seeing, or maneuvering under fire to a flanking angle, or waiting for the tank to become separated from its infantry support, and then striking from an unexpected direction. None of these solutions is easy. None of them is consistently survivable for the gun crew, but they are viable, and ZIS-3 crews execute them repeatedly, enough that the Tiger's reputation for invulnerability begins, over the course of 1942 and 1943, to develop exceptions. The arrival of the Panther in the summer of 1943 presents a different problem, and the solution to the Panther problem is what consolidates the ZIS-3's reputation and earns it the name the German tankers give it. The Panther, the Panzerkampfwagen 4, is the German response to the T-34. It is a medium tank by German designation, but a heavy tank in everything that matters. It weighs 44 tons. Its frontal armor is 80 millimeters sloped at 55 degrees, producing an effective protection equivalent to approximately 140 millimeters of vertical plate, and its main gun, the 75mm KWK-42L70, can defeat virtually any Soviet armor it encounters at ranges up to 1,500 meters. On paper, the Panther is a tank that the ZS-3 cannot kill from the front at any reasonable combat range. The paper is not wrong about the ballistics. It is incomplete about the war. What happens at Kursk in the summer of 1943 is the event that defines both the Panther's reputation and the ZS-3's answer to it. And it is necessary to understand the scale of what Kursk represents to grasp why the gun's performance there matters so much. The German plan, Operation Citadel, calls for two massive armored thrusts from the north and south to pinch off the Kursk salient, encircle the Soviet forces inside it, and destroy them in detail in the manner that had worked so catastrophically for the Soviets in 1941 and 1942. The Soviet plan, developed over months with intelligence from multiple sources, including, by some accounts, the British-supplied Enigma decrypts, is to allow the German attack to begin, absorb it against prepared defensive belts, and then counter-attack when the German armored force has been exhausted. The defensive preparation is the most extensive the Red Army has ever attempted. 6 defensive belts, hundreds of kilometers deep, with artillery densities reaching to over 300 tubes per kilometer of front at the critical points. ZIS-3 guns are embedded in this defensive system in their thousands, dug into hull defilade positions, camouflaged under nets and branches, with registered targets at every approach lane, with alternate positions prepared and range cards calculated for every likely line of advance. When the German attack begins on July 5, 1943, the Panthers of the 10th Panzer Brigade's 2 battalions, the first large-scale operational deployment of the new tank, immediately encounter problems that have nothing to do with the ZS-3. The Panthers suffer catastrophic mechanical breakdowns in the first 2 days, losing nearly half their strength to transmission failures, engine fires, and final drive failures that the accelerated production schedule has not been able to solve. By July 7th, historians estimate that barely 160 of the original 200 Panthers are still operational, out of attrition to defects rather than combat damage. But what the surviving Panthers then encounter as they push south toward Prokhorovka and northwest from the southern salient is the ZIS-3 in its element. Soviet gun crews have been given detailed intelligence on the Panther's armor and its weak points. They know the frontal plate cannot be defeated at normal engagement ranges. They have been instructed in the clearest possible terms that engagement of a Panther from the front is to be avoided, and that the solution to a Panther is the flank shot, the rear shot, the turret ring, the running gear. The gun crews of the Soviet 5th Guards Tank Army and the Voronezh Front's anti-tank artillery regiments have been practicing these engagements for weeks, using captured German vehicles and wooden mock-ups at the correct dimensions. They understand, specifically, that the Panther's side armor, 60 mm at a slight angle, can be defeated by the ZS-3's BR-350B projectile at ranges up to 800 meters, and that the running gear, the tracks, the road wheels, the final drives that are already failing from mechanical weakness can be damaged by near misses that would be irrelevant against heavier side armor. What the German tank crews experience in the choke points and gullies and sunflower fields of the Kursk salient is that the ZS-3 is everywhere. It is behind the wall, it is in the gully on the right. It is in the farmhouse that did not look like a farmhouse. It fires, and if the first round does not kill the tank, it displaces before the tank can locate it, and it fires again from a position 50 meters away. The Panther's great gun is devastatingly effective against Soviet T-34s and T-70s at ranges where the Soviet guns cannot penetrate Panther frontal armor, but the battle is not being fought at those ranges in those circumstances. The battle is being fought in terrain that the Soviet engineers have spent months preparing, in positions that cover every approach, in a defensive system so deep that punching through one belt merely exposes an attacking column to the next. And the ZIS-3, mobile, low, fast, crewed by men who have been doing this for a year and a half and understand it in a way that cannot be taught in a training ground, is the instrument of that defense. The after-action reports the Wehrmacht's Panzer crews file after Kursk are documents worth reading carefully because they are trying to describe something that defies the framework those crews are using. The Panther is supposed to be superior, its armor is superior, its gun is superior, its optics are superior, and yet it is being killed by a gun that is supposed to be incapable of killing it. The answer is in the details of engagement geometry, in the accumulated tactical skill of ZIS-3 crews, in the specific preparation of the terrain. But the German tank crews, writing in the aftermath of a battle they have lost, reach for a simpler explanation. The gun is too good. The gun is everywhere. The gun kills things it should not be able to kill. Tier killer, some of them write. Beast killer. The name arrives at a specific moment that historians cannot precisely date because it is not coined in any single document. It accretes from a dozen after-action reports, from conversations between tank crews in maintenance depots, from the specific shorthand of men who face a threat often enough that it acquires a personality. The Tiger is the German army's own beast, the apex predator of the armored world, and the gun that kills it, not routinely, not easily, but often enough to matter, is the beast killer. That the ZIS-3 also kills Panthers, and Panzer IVs, and Panzer IIIs, and half-tracks, and artillery tractors, and infantry in the open, and strongpoints, and machine gun nests, and everything else a divisional field gun is asked to kill, is almost beside the point. The name sticks because the tank is the symbol of German armored power, and the gun kills it, and in a war defined by armor, that is enough. The operational record of the ZIS-3 through 1943 and into 1944 is inseparable from the Soviet artillery transformation that is occurring simultaneously. By the summer of 1943, the Red Army's artillery has been reorganized into a system of centralization and mass that bears no resemblance to the scattered piecemeal artillery of 1941. Artillery corps, artillery divisions, breakthrough artillery divisions, these formations concentrate thousands of guns at the decisive point and deliver fires of a density that German defensive positions cannot withstand. The ZIS-3 exists within this system at multiple levels. It is the divisional gun, the standard weapon of the Rifle Division's artillery regiment, present in every formation. It is the anti-tank gun of the anti-tank brigades that form the mobile reserve behind every sector of front. And it is the direct fire support weapon that moves with the assault infantry, placed in positions that allow it to engage German machine gun positions, fortified buildings, and light armored vehicles at point-blank range. The men who operate it are as important to the story as the weapon itself, though they are harder to recover from the historical record. Soviet artillery records of the mid-war period are detailed about units and equipment and ammunition expenditure and tank kills attributed to specific batteries, but they are often silent about the individuals who composed those batteries. What survives is fragments, a citation here, a post-war memoir there, a regional newspaper account from 1965, and from these fragments, certain things become clear about what it means to serve a ZIS-3 in combat. A ZIS-3 crew is typically 6 men, a gun commander, a layer, a loader, 2 ammunition carriers, and a driver for the towing vehicle. The gun commander is responsible for selecting the position, calculating the engagement, and directing the fire. The layer is the man behind the sight, who traverses the gun and sets the elevation and releases the firing mechanism, a job that requires absolute steadiness under fire, because the moment between acquiring a target and firing the round is the moment when the enemy is also looking for the gun's muzzle blast. The loader's job is mechanical speed. The ZIS-3's semi-automatic breech ejects the spent case on recoil, but someone must place each new round in the chamber, and at a rate of 15 rounds per minute, the loader's hands must move continuously without error, because an error in loading can jam the breech at the exact moment the crew most needs to fire. What the crew lives with in the sustained combat of 1942, 1943, and 1944 is an existence defined by alternating extremes of inaction and violence. There are hours, sometimes days, in which nothing happens. The gun sits in its position, camouflaged, while the crew maintains it and rests and waits. And then the tanks come, or the artillery barrage begins, or the infantry attack develops, and the period of violence is compressed into minutes, during which everything that happens is happening faster than thought, and the crew either functions or it does not. Crews that function are credited with tank kills, with strong point reductions, with infantry attacks broken up. Crews that do not function are not mentioned in after-action reports, because the dead do not file reports and the survivors often cannot say precisely what happened. The gun's vulnerability is the gun crew's vulnerability, and it is a real one. The 4mm shield that protects the crew from rifle fire and splinters does not protect them from the thing that actually destroys ZS-3 positions: the tank's coaxial machine gun at 300 meters, the artillery round that lands within 10 meters, the mortar bomb that drops into the position from above. Gun crews on the Eastern Front have a life expectancy that varies enormously depending on the tactical situation and the period of the war, but the statistical record is not encouraging. Soviet anti-tank artillery units suffer some of the highest casualty rates of any branch of service in the Red Army because the nature of anti-tank combat places the gun in a position where it must engage the most dangerous weapons the enemy possesses at ranges where those weapons can engage back. The winter fighting along the Eastern Front adds a layer of difficulty that is worth understanding specifically, because the ZIS-3 is not exempt from the cold that defines operations from October through April across most of the theatre. The recoil mechanism is hydraulic pneumatic, and Grabin has designed it to function at temperatures down to approximately -40 degrees Celsius, but function is not the same as function well, and crews operating in extreme cold learn quickly that the gun requires maintenance routines that the manual does not fully describe. The recoil oil must be checked before every firing sequence. The breech mechanism must be kept clean of ice and snow that can impede the semi-automatic function. The ammunition must be stored in a manner that prevents temperature differentials from affecting propellant performance. A round that has been sitting in -30-degree cold for 12 hours behaves differently at the moment of firing than the same round stored in a dugout. Experienced crews develop informal practices to manage these variables, practices that exist nowhere in the official documentation and are transmitted by word of mouth from veteran crews to replacements. By the time Operation Bagration begins in June 1944, the massive Soviet offensive that destroys Army Group Center in a matter of weeks, the operation that some historians regard as the most decisive campaign of the entire war in Europe, the ZIS-3 is present in numbers that stagger the imagination. Soviet artillery at the point of the main breakthrough reaches densities of over 250 guns per kilometer of front. The preparatory bombardment, 3 hours and 20 minutes long, expends ammunition stockpiles that have taken months to accumulate. When the Soviet infantry and armor follow the artillery into the German positions, they find defenders who have survived the bombardment in a state of shock that reduces organized resistance to a series of disconnected local actions, and the ZIS-3 moves forward with the infantry, covering the advance, engaging the strong points that the preparatory fire has not destroyed, protecting the flanks of the advancing columns from the German armored counterattacks that are the only possible answer to a breakthrough of this magnitude. The German counterattacks at Bagration are largely futile. Army Group Center has been stripped of its armored reserve, to feed the fighting in other sectors, and what remains fights with the courage of men who understand that the situation is irreversible but fight anyway because fighting is what soldiers do. The ZIS-3 batteries that meet these counterattacks are now operating in an entirely different mode than the guns of 1941. They are the instrument of an army that has learned, at an appalling cost, everything about how to fight this war, and the learning is visible in every tactical detail. The positions correctly chosen, the range cards correctly computed, the alternate positions prepared, the displacement drills practiced until they are automatic, the ammunition properly managed, the communication between gun commander and battery commander and regimental commander functioning the way communication is supposed to function. The German counterattacks break against this system the way the Soviet counterattacks of 1941 broke against the German anti-tank guns. Not because the individual soldiers are worse, but because the system behind them has been outbuilt. After Bagration, the strategic picture of the Eastern Front ceases to be in doubt. The Red Army will reach Berlin. The question is only the cost, and the cost in lives remains enormous even when victory is no longer uncertain. The ZIS-3 goes forward, kilometer by kilometer, through Poland, through Hungary, through Romania, into the eastern approaches of Germany itself, until on the morning of May 8, 1945, the guns that are still in service fall silent and remain that way, and the war in Europe is over. What the weapon's post-war life reveals about its nature is worth noting, because weapons of exceptional quality accumulate a documentary record that eventually captures what the wartime records, written in the compressed urgency of an active campaign, cannot fully express. The ZIS-3 remains in service in the Soviet Army through the 1950s. It is exported widely to China, to North Korea, to Egypt, to Syria, to Vietnam and beyond. It fights in Korea, in the Arab-Israeli wars, in conflicts across Africa and the Middle East. In some cases, it is still appearing in active service in regional conflicts as late as the 1980s and, by some accounts, beyond. No gun serves in this many theaters over this many decades unless it is genuinely excellent, and the ZIS-3's longevity is the most honest testimony available to what Grabin's design achieved. The production total, 103,000 guns in 4 years in the conditions of a country simultaneously fighting the largest ground war in human history, is a number that belongs in a different category of human achievement than the mere manufacturing of military hardware. It represents the decision, made in the autumn of 1941, to build the gun that could be built rather than the gun that could be imagined, and to build it by a man who understood that the war would not wait for perfection. The committees that controlled Soviet arms procurement were not wrong that the ZIS-3 was unauthorized. They were wrong that this mattered, and Grabin was right that it did not. And the subsequent history vindicates him in the most complete way possible, not by the approval of his superiors, but by the gun itself, sitting in its camouflaged position in the dust and cold and smoke of the Eastern Front, firing. The German tankers who coined its nickname did not mean it as a compliment in the conventional sense. They were trying to describe a threat that had exceeded the parameters they had been given, a gun that performed beyond what the published technical specifications suggested it should be capable of. But language borrowed from German tank crews has a precision of its own. They knew what a beast was. They were inside one. And the thing that killed it again and again on the steppes north of Kursk and in the breakout from the Vistula and at the walls of Warsaw was not a heavier gun, not a more sophisticated gun, not the product of better engineers or more advanced metallurgy. It was a gun that weighed 1,150 kilograms and could be lifted over a ditch by 4 men and fired 15 rounds per minute in minus 40-degree cold by a crew who had learned to do it by the hardest possible education. The beast killer, the ZIS-3. The gun that was built because there was no time not to build it, and that turned out, in the most demanding possible conditions, to be exactly good enough to win. If this story hit you, like and subscribe. We find these forgotten stories every single day. The real question the Zs-3 leaves open is one the engineers on both sides of the war were arguing about in real time, and historians still debate. Was the advantage in armor or in the gun that defeats it? And does the answer change everything about how we understand what happened on the Eastern Front? Could the war have ended differently if the Panther's mechanical problems had been solved in time for Kursk? And watch this next video. You are not going to believe what these men did.